Welcome to clickmyproject.com. Yeah, let us discuss about the inherent raindrop modeling, detection and removal in video. Yeah, let us discuss about the many state-of-the-art computer vision algorithm and designed to work in well-posed visibility conditions. Though this assumption may hold of most indoor and simulation scenarios, environmental noise can be badly influences their performance in outdoor setting. For example, in surveillance applications or in driver assistance systems where a camera is mounted behind the window seats of moving vehicle. However, a proper operation in the presence of rain in the security. So, a relevant P requires to many applications, particularly on a broad mobile vehicles. So for example, image registration accuracy declines the presence of raindrops on the windshield due to the mismatched features. So in this proposed work, a method that automatically detects and removes inherent raindrops. So the core idea is to exploit the local, spatial and temporal derivatives of raindrops. So the to encompass the idea, we first model so the inherent raindrops using a law of physics and detect the raindrops based on this model in combination with motion and intensity temporal derivatives of the input video. So having detected the raindrops, we remove them and restore the images based on analysis that some areas of raindrops completely occludes the scene. So and some other areas occlude only partially. So for partially occluding areas, we restore them by retrieving as much as possible information of the scene, namely by solving a blending function of detected partially occluding areas using the temporal intensity derivative. So for completely occluding areas, we recover them by using the video completion technique. So experimental results using various real videos, so the effectiveness of our method. Yeah, let us discuss about the flow diagram of the process. So this is the overall flow diagram, and this data set we collecting the videos of that is a rain video, and then the input video is getting. So whatever may be video, it will be getting in the video, and then pre-processing. So in this pre-processing step, the input video it should be converted as a frame. So in number of frames it should be converted, and then filtering process. So in the filtering process, there are two methods in apply. One is a raindrop reduction and another one is a raindrop removal, and then finally performance analysis. So in the performance analysis process, we calculating accuracy, precision and recall of the process. Let us consider detailed exploration of the all the frames. So in frame conversion process, we using that. Yeah, first of all, the input video to select the path and file name to video given format upload the movie player. So that file to be loaded after the play the video, it will be convert a frame, row and column wise of the frames. So at the same time, for all the frames will be converted in the number of the panels. So that is the pre-processing step. So the frames all will be right at a particular folder. We need to display our values for the frames. So the video files consist of frames. So these frames when appears as an array more than our perception of vision gives a sensation of an object moving before us by looking just at the screen. So on which frames its priority should be high. So the scan one frames are fundamental entity in video. So raindrop reduction real scenes with ground truth. So we create a data by dropping a water on a transparent panel as a ground truth and tasking the videos. So in the filtering process, our method environment assumes it's sufficiently textures. So hence it is used for the so we investigate how significant the absence of textures influence the detection and accuracy. So and then rain removal. So the raindrop removal. So the raindrop removal, the synthesized raindrops are generated on the video and used as an input. Our method is compared with the proposed method by the Wilshire. So in the a sufficient description for the removal algorithm, and this is not compared here. So we show few results of removing raindrops is being handled by the some mounted camera as like that. So second rows where we can using the see some improvement of the process. So finally we calculating the performance analysis for the accuracy, precision and recall of the process. So these are the overall flow diagram of the process. Yeah, let us discuss about the running procedure for the process. So click the main file and then run. It has a time to execute the file. So first of all we take an input video and then the processing will be shifted. So the input video will get in the rain video. So we will finally remove the raindrop for the particular frame of the process and then finally get the performance measure of the process. Yeah, here we taken the one data set, so I will take the data one of open. So it should be played for the original video. It's take a running time to display the video of the process. The input video it should be displayed. Yeah, installation is mentioned, and the movie player it should be played for it take time to reduce the process. So the movie player it should be loaded. So that is loading the data source. Then the video should be played. So this is the movie player. So on this movie player, it's take a time to run the video. So this is the original video. So the original video should be played. It has some raindrops are presented in the video. So I mean they're presented in the frame. So this is a sample raindrop video. Finally it should be deducted. So the video it should be converted to the frame. So frame 1 to up to frame 50. So the frames are converted in the pre-processing step. Yeah, this is the particularly there are 50 frames. We only selected the one frame. So this is the selected frame of the process. And then the next one is this is also the second frame of the process. So the feature extraction process here we are using a SIFT feature extraction process. The raindrop removal. So that's the raindrop it should be deducted by using the red circle. So this is the SIFT feature extraction process is implemented in the process. Let us discuss about the OF offline and then level set region. So these are the level set region for the particular formula of the process. So and then it's very easily good to calculate the level set regions of the process. So this is the visualization of rain removal stroke width. What width will be presented in the so in a particular raindrop it should be highly intensity of the process. Finally the raindrop will be removal. Finally the raindrop will be removal for particular intensity of the process. So and then give the performance measure. So in the performance measure we calculate in the precision, recall, F measure and fall positive. So these are the performance of the process. So overall running. So these are the overall running procedure for the process. Thank you for watching this video. Thank you for listening this video.